Welcome, everybody, to a lovely Friday night engagement here at CERC, the Schoodic Education and Research Center, an old Navy base turned into a research and learning center, one of 19 that exist in affiliation with the Park Service across the United States. And tonight's program is in particular brought to you by an arm of the Research and Learning Center, and that's the Schoodic Institute Bird Ecology Lab. My name is Seth Benz, and I'm the director of that lab, and we investigate things like the timing of when things happen in nature. The fancy word is phenology, so we're looking at when things leaf out and fruit, what insects eat those fruits, what birds in particular come and get those insects. We're also looking at things like dragonfly migration and insect migration, other insect migration. So we're studying migration in general. Anything with wings that migrates, we're researching here. Bats included. And in September, we're going to have a program on migratory bats. So you'll see more about that if you go to the CERC Institute website, circinstitute.org, and you can learn more about that. I'm excited tonight for a number of reasons. One, of course, is bringing my good friend from Pennsylvania here to be our guest speaker tonight, and I'll introduce him in just a second. But we also have a program that is called the Dixon Schoodic Scholars. And tonight in the audience among you are, I think, 12 or 13 of 19 people who have been selected as scholars here at CERC. These folks are people who are doing scientific research, or they're artists, or they're storytellers, they're botanists. They've been engaged in, generally speaking, natural history work throughout the region, stretching from all the way down at the mouth of the Duck Trap River in Mid-Coast, Maine, all the way up the St. Croix River to the border of our state and our country with Canada, of course. So if I could, I'd like to get the Dixon Schoodic Scholars to just stand up briefly. We won't say their names individually. So the idea behind the scholars is that CERC has provided the scholars with a modest stipend over the next 2 years, and we've given them housing privileges here on campus. And the idea is simply to have them come here and help us to create community around that which we think is a really great thing, and that's the study of nature. Nature and art, nature and the sciences. We don't really make those splits. We're just happy to have all of you folks with us, and we look forward to creating some foment among the scholars so that we get some ideas. There's some really exciting ideas coming out of this group, and this is the first time that we're actually assembling since the idea emerged in late winter. The festivities this evening, following the presentation, we're going to have some dessert for the public, as well as the scholars. So you can avail yourselves of that dessert. I'm hoping it'll be out by the time we're through with the presentation. And you'll hear a little bit about this in the program tonight, but we're featuring Birds and Beans shade-grown coffee. So it's a special coffee. We'll have, for sure we'll have decaf. I'm not so sure if we're going to have regular, although you'll need supercharged for those of you driving home, so you might want to try that. But our our guest speaker tonight, Scott Weidensaul, is closely affiliated with Birds and Beans. In fact, some would say he's one of the faces of that particular company and effort. There are marquee birders and popular authors, of which Scott is one, who represent this particular company. And the idea behind it is that most Americans we love to drink our coffee, and I think there's only one coffee company in the United States that actually grows the beans, and I think it's in Hawaii. So most of our coffee and tea comes from south of our border in Central and South America. And we all know that our neotropical migrants, the little passerine birds that we love so much, the warblers and the tanagers, thrushes, they go from this latitude all the way into Central and South America to winter over. And it's important that their habitat is preserved on their wintering grounds. Shade-grown coffee is very vital to their winter health and survival. And I'll leave it at that, and I'm sure Scott will say a few more things about that later. So tonight, it's really my pleasure to introduce to all of you a good friend. Both of us are from Pennsylvania. Both of us have had some time separately and together at a place called Hawk Mountain Sanctuary, where we studied the movement of birds of prey migrating south. Scott has gone on to fame and fortune. He started out as a journalist with a small local newspaper in Pottsville, Pennsylvania, just north of Hawk Mountain. Pottsville is known for a couple of things. One was a tar-infused river called the Little Schuylkill River. During the early days of oil exploration and those sorts of things, energy consumption, we polluted some of our rivers. The Little Schuylkill was one of the ones that was first among rivers to be cleaned up. And Scott was around reporting about that kind of stuff back then for this little newspaper. The other thing about Pottsville is that it's the home of the oldest brewery in the United States, Yingling Beer. It's very good. Check it out sometime. So you're getting several commercials. There's a beer commercial and a coffee commercial. So from those days in Pottsville, Pennsylvania, and Hawk Mountain Sanctuary, both Scott and I ended up at a place at different times again, but this was at Hog Island in Midcoast, Maine, in Bremen, the Hog Island Audubon Camp. Some of you, I think, have been. How many people have been to the? So there's a contingent that's out here. Yeah. So Hog Island is like Mecca for Audubon. People would go there. It was established to bring educators to sort of learn the Audubon model of studying nature. And so both of us have had the pleasure of instructing there and now being directors there in my past, and he is currently an acting director there. And in fact, that's what brought him to Maine. He's up here for the next, the remainder of the month, helping instruct and lead people from all over the United States coming to spend a week on Hog Island. So Scott is also a very prolific author. He's written a variety of books. Tonight's presentation is going to be about one of those books that has everything to do with bird migration. It's called Living on the Wind, The Miracle of Bird Migration. And I think that you will very much enjoy the slides that come with his presentation. I also wanted to say that he has a book that's currently in production, or at least getting to the point of production. And this is a Peterson guide on owls of North America, and Mexico, and the Caribbean. Great. So and that'll be out in a year and a half or so? Spring of 2015. So you can look forward to that. It's very prestigious to be an author of the Peterson Field Guide series. Roger Tory Peterson was someone who we revere and was someone who taught at Hog Island a little bit before the two of us ever got there. So tonight, without further ado, I would love to introduce to you my good friend, fellow colleague, Scott Weidensaul.
Thank you. Thank you very much, Seth. And the technology works. This is so nice when you have an expert like Jim up in the booth who actually knows what they're doing. It's a real delight to be here. This is the last time I was up here. This was a Navy base. It's an amazing transformation to see what they've done at CERC. Is the sound level okay? It's very. I'm not used to this little lavalier thing hanging right in front of my face. As Seth said, I still live in Pennsylvania, and I've been fascinated by bird migration all my life. And Hawk Mountain, the place that Seth mentioned, it's kind of rare that you can have a single day that you can point to and say, this day changed my life. But when I was 12 years old, I grew up not too far from the sanctuary, and I had been campaigning for a while for our family to take a trip there. And finally, one day, my younger sisters and I were off school, so it must have been like Columbus Day weekend or something. And we were making a serious attempt to try to kill each other. And my parents said, we got to get the kids out of the house. Why don't we take them to this Hawk Mountain place Scott keeps talking about? And it's this high promontory on the Kittatinny Ridge in the Appalachian Mountains. And every fall, you have this flood of 20,000 hawks and eagles and falcons that come pouring down the Appalachians past the lookout. And we didn't know anything about the mechanics of what made this migration work, the way that you have to wait for the passage of a cold front with northwest winds that sparks the migration. But we just kind of by dumb luck picked the best migration day of the year. And I was just on fire after my little golden field guide that I'd been studying and my battered old pair of binoculars, and practically dragged my family up the mountain. We're sitting up in the rocks and the wind's blowing and there are hawks everywhere. And I had been studying, I'm 12. I had been studying the book for weeks and weeks and weeks, and nothing in the sky looked anything. You know what I'm talking about? Nothing like what was in the book. But when you're 12, that does not stop you. And so I'm sitting there saying, there's a sharp-shinned hawk coming in. This is a Cooper's. Oh, there's a peregrine. And I was going on and on. And finally, this woman who was sitting on a rock right ahead of us turned around and kind of fixed me with her eye and said, son, sit down. You don't know what you're talking about. And then she said, okay, now watch this one coming down the ridge. See how it flaps a few times and then glides, and then flaps a few times and glides. That's an accipiter. That's one of the forest hawks, like a sharp-shinned hawk. See how this one's wings kind of bow when it glides? That's a red-shouldered hawk. And 3 things happened to me that day. I got hooked on the Appalachians, the notion that this mountain range that I was growing up in was this migratory flyway that was funneling birds from Greenland and the Arctic all the way to Argentina and Chile that were flying right over my house. And I got hooked on raptors to the extent that, over the years I've become, a hawk and owl bander. I've, tracked golden eagles all the way down to little tiny saw-whet owls. We banded 4,000 saw-whet owls last fall. There's a virus. I'm convinced there is a virus that you get infected with that makes you a raptor nut for the rest of your life. But the other thing that happened to me that day was that I got hooked on migration. The notion that, the realization, I should say, really, that the whole world is passing through my backyard twice a year. That birds that were born at the farthest reaches of the hemisphere were coming to my house and sometimes passing over it in the middle of the night when I was asleep. And this recognition that the world was so much bigger and more dramatic than I realized. And I've been chasing migration ever since. And back in the mid-90s, I had the opportunity to set everything else aside for about 6 years and travel up and down the Western Hemisphere following bird migration, just going wherever the birds went between Alaska and Argentina. And it was like getting paid to eat ice cream. I mean, for a bird nut, it really was the most fun I will ever have professionally in my life. And so what I'd like to do today is just tell you about bird migration and talk to you a little bit about how birds are able to do what they're able to do, why they do what they do, the amazing things that we're learning that they're doing, and I can speculate about some of the amazing things that we don't know yet that these birds are doing. But if there's one take-home message that I want you to carry with you at the end of the program today, it is the universality of bird migration, the ubiquity of bird migration. At every moment of every day, morning, midnight, doesn't matter, there are birds somewhere in the skies of the Western Hemisphere migrating. Now, if it's spring or fall, which are the two big pivot points of the year, the seasonal fulcrums, there are so many birds migrating. Especially in fall, when you have somewhere between 20 and 100 billion migratory birds pouring out of North America. There are so many of them that even the most ignorant, unobservant dolt, if nothing else, recognizes that there are flocks of geese flying overhead and robins hopping around in their yard. But migration goes beyond these obvious watersheds. In the first week of July, when we are still digesting our 4th of July hot dogs and hamburgers and corn on the cob, Hudsonian godwits like this one are going to be taking off from the shores of the Beaufort Sea and the Arctic and heading south on their fall migration. At Hawk Mountain, where I live, in January, you still have goshawks and golden eagles and red-tailed hawks, the last few of them heading south on their fall migration. Fall migration extends over about 7.5 or 8 months. And spring migration does too, and there's a tremendous amount of overlap there. So, and even in parts of the world where you wouldn't think that migration was even necessary, we're finding that many species of birds are crossing hundreds of miles of distance or thousands of feet in elevation in seasonal migrations, often to find seasonally abundant sources of food. Now, here in the Western Hemisphere, we think of migration as this linear kind of north-south phenomenon. The birds go south for the winter. The fact of the matter is these birds are ping-ponging all over the hemisphere in every conceivable direction. You have birds like Arctic warblers that nest in Alaska that migrate to Borneo. You have birds, another Arctic breeding bird, the northern wheat ear. The northern wheat ears that breed in eastern Canada migrate east across Canada, across the Atlantic Ocean, down through Greenland, through Europe, and into Western Africa. Whereas the ones that breed in central and western Canada and Alaska go the opposite direction, down across all of Asia and you're in East Africa, basically wrapping the world in this wishbone of movement. And then you have birds like this great shearwater, these pelagic seabirds, which are the greatest migrants of all. These are birds that are crossing immensities of space the way we cross the street for groceries. Albatrosses that will go out on 4,000-mile foraging expeditions in a matter of a couple of days. Birds that are drawn in places like Monterey Bay off California, where you have shearwaters that were born in Tasmania and albatrosses born in Hawaii or Japan and storm petrels from Antarctica drawn to that one place at that one time of the year by the seasonal explosion of food. There are so many birds migrating that even the night sky is alive with the movement of migratory birds. In fact, especially the night sky. Most birds migrate at night, even the ones that are normally active in the daytime. Vireos and flycatchers and thrushes and orioles, these birds take off at night because the night sky is cooler, it's moister, they're less likely to suffer from dehydration, there are fewer predators, the air tends to be calmer and less turbulent. And so these birds take off after dark by their tens of millions, flying overhead over this completely unsuspecting populace down below when we're sitting inside in the flickering blue light of our televisions, unaware of the fact that if you could strip away the darkness and see what was going on overhead, it would be the greatest wildlife spectacle in the world. Back in the days of the ancient Greeks and Romans, they talked about the music of the spheres, the sound that the great crystal spheres into which the stars and the moon and the sun were embedded, the sound that these spheres made as they swirl through the heavens. It was the sound of birds. It was these little delicate flight notes that these birds drop as they migrate. That was the music of the spheres. So we're dealing here with something that's incredibly old in human society. I mean, we sat in our rock shelters 30,000 years ago, scratching our fleas and watching the storks and cranes and waterfowl marking the passage of the seasons overhead. We've been fascinated by birds for as long as we've been human. But it's really only been within about the last 100 years that we've begun to understand how these birds are able to do what they're able to do, the mechanics of migration, how they're able to find their way. And really only within about the last 25 or 30 years that we've begun to understand the stresses and the strains that we're putting on the natural systems that allow these birds to do these incredible things. Because birds do incredible things. Now, as I mentioned a moment ago, I had an opportunity back in the late 90s to follow bird migration. And I made a joke that this was like getting paid to eat ice cream, but it really wasn't. I mean, for a bird watcher, this was the ultimate experience. But one of the things that surprised me as I got into this story was how much of this was a human story, as well as a story of birds. This is a story of people from a host of different economic and ethnic and social and educational backgrounds. Retired electrician in Alabama, campesinos in Mexico, landowners in Argentina, native elders in Alaska, professional wildlife biologists in academia or in government service. People from just a myriad of different backgrounds that were united by the recognition that a world without migratory birds would be too dull and depressing to even contemplate. And so they're doing everything in their power to try to make sure that that doesn't happen. Because birds do amazing things. Anybody recognize that bird? Yeah, just say it. Ah, yeah. Well, it's actually not a black-capped chickadee. It's not a black and white warbler. It is a black-pole warbler, and this is a bird that breeds in northern Maine, and that's a male black-pole warbler in the springtime. It has a very high-pitched, thin, repetitive trill call. If you're of a certain age, you may not be able to hear black-pole warblers anymore. But in the fall, this is what black-pole warblers, most of them look like. They're greenish and streaky. The field mark you want to look for is the yellow foot pads there. And this is a bird that breeds not just in Maine, but across the entirety of the boreal forest in northern North America. So that whole huge area from Newfoundland all the way across the northern United States and southern Canada and up into Alaska. This is a small bird. 4.5 to 5 inches long. They weigh less than half an ounce. You could mail 2 of those anywhere in the country for a first-class stamp. Please don't. Fish and Wildlife Service doesn't like when you do that. But the point is, this is a tiny little bird that weighs barely more than air, and it's going to fly from way up there to down about here somewhere, deep in the heart of South America. This bird has this incredible migration from northern North America to the Amazon and Orinoco Basin in South America. It's got an incredibly long way to go, and it doesn't go even by the most direct route. So let's say that you're a black-pole warbler born in western Alaska, and autumn is coming on. It's time for your migration. The first thing you're going to do is, I look at that map and I see a perfectly serviceable land bridge connecting the 2 continents, but that's not what they do. They take off from west to east, and they fly in 1 or 2 big nonstop flights across all of Alaska and Canada. And they wind up in late September and early October along the northeastern coast, basically from about Cape May, New Jersey up to Nova Scotia. And they wait there for the right conditions for the next stage of their migration. And the right conditions for them, as it was when I was a kid when I went to Hawk Mountain for the first time, is the passage of a cold front, a night when you've got strong northwest winds blowing. Now, again, I'm looking at that map and I'm thinking, if I'm going down here, well, okay, the land bridge is out, but there's Florida and those nice islands you can hop. But that's not what they do. When the conditions are right, these birds take off by the millions just after dark, and they fly out into the western Atlantic. And they fly 80 or 90 hours nonstop from the northeastern coast of the U.S. to the northeastern coast of South America. 80 or 90 hours with no food, no water, no rest. If they stop beating their wings for even a moment or two, they're going to plunge into the water and die. They will beat their wings something like 3 or 4 million times in the course of this passage. And then they'll fly for another 2,500 or 3,000 miles further, deep into the heart of South America. A tiny little bird, and the fuel for that migration are a couple of grams of fat that would probably fit on the back of my thumb. If they were burning gasoline instead of fat, the calculation is that they would get about 720,000 miles to the gallon. So stick that in your Prius and smoke it. That's the definition of fuel efficiency. Birds do incredible things. This is an Arctic tern. We've got Arctic terns breeding on the islands off the Scudic Peninsula here at places like Petit Manan and Eastern Egg Rock, Botanicus. Arctic terns, when I wrote my book, which came out in 1999, the Arctic tern was the acknowledged long-distance champion of all migrants because they breed in the highest latitudes of the northern hemisphere. They fly all the way down to the highest latitudes of the southern hemisphere, and if you just draw some lines on maps, a little back-of-the-envelope calculation, the estimate was that they're probably flying between 22,000 and 25,000 miles a year, which is incredible. But then as tracking technology got smaller and smaller, we were able to start putting satellite transmitters in other seabirds. We discovered that some of them fly even farther, that sooty shearwaters and short-tailed shearwaters that breed in Tasmania and New Zealand that make these huge figure eights across the Pacific Ocean and spend the summer in the Bering Sea and then make huge figure eights across the Pacific Ocean back to Tasmania are flying 40,000 miles a year. And then 2 years ago, Ian Stenhouse from here in Maine and a couple of other colleagues put light-sensitive geolocators on Arctic terns breeding in Greenland and Iceland, with the first time they could track these much smaller and lighter birds on their migrations. And it turns out that these Arctic terns in the Atlantic Ocean are making huge figure eights down the Atlantic Ocean to Antarctica, going partially around Antarctica. Some of them are actually going up and wintering in the Indian Ocean and then coming back, and they're traveling 47,000 miles a year. All hail the king. Just in the last 2 weeks, a paper was published on Arctic tern migration out of the Netherlands. These birds fly even farther. They fly 51,000 miles a year. Next year, Dr. Stenhouse and I and a colleague of ours in Alaska are going to be putting light-sensitive geolocators on Arctic terns in Denali National Park in Alaska, which winter in the Pacific, which is a very much larger ocean. And if I were a betting man, I would bet the farm that those terns go farther than 51,000 miles. We will find out. Birds do amazing things. And if you want to understand this global migration system, one of the best places to go to understand it is one of the most beautiful places that I've ever been. It's called Eisenbeck National Wildlife Refuge. It's in extreme western Alaska. It's that part of the Alaska Peninsula right where it starts breaking up into the Aleutian Islands. And the birds that breed in Eisenbeck literally fan out over 3/4 of the Earth's surface every year in their migration. And they're birds like the American golden plover, beautiful shorebird. American golden plovers have a very similar migration route to the blackpoll warbler. The ones that are breeding in Alaska fly west to east across all of Canada. They stage up in Newfoundland and the Maritimes, feeding on blueberries and crowberries and insects. They build up their fat reserves. They take off across the western Atlantic. They fly down to South America, and then they continue all the way down to the southern cone of South America and spend the winter in places like Chile and Argentina and Uruguay. But in the same soggy patch of tundra where you have American golden plovers nesting, you also have Pacific golden plovers, which are almost identical except they've got more white coming down the side and their wing feathers are a bit longer. And they go in the other direction. They take off from Alaska in late summer and early fall. They fly west across the Bering Strait. Many of them fly down along the rim of the Pacific to winter. And a portion of the population actually flies out into the Pacific Ocean halfway across the Pacific and winters in Hawaii. It's an astonishing thing to think about. But that doesn't even count as the most amazing migrants coming out of Eisenbeck. The most amazing Alaskan migrant, in fact, probably, for my money, the most amazing migrant in the world is that bird up there, which, even if you're an avid birder, may not be one that you recognize. It's called the bar-tailed godwit. It's a shorebird. It's about the size of a big dove or a small pigeon, long, skinny legs, that long, classic godwit ice-pick bill. And bar-tailed godwits breed, this particular subspecies breeds in western Alaska and eastern Siberia. And every fall, by which I mean late August, because we are talking Alaska after all of those godwits gather down there on the hook of Bristol Bay, where it goes out into the Alaska Peninsula. And they undergo a phenomenon that is typical of migratory birds. This is a phenomenon you have seen at your last family reunion. It's called hyperphagia, which is a polite way of saying binge feeding. Think about Uncle Ralph, though, just for a moment. They eat and eat and eat and eat and eat until they cannot possibly eat anymore. They more than double their weight in about 2 weeks. By the time they're ready to migrate, they are 55% fat. They jiggle when they walk. They feel like a water balloon when you're holding one. There's just these astonishingly thick subcutaneous fat layers. It's like they've put on a fat suit. They are so fat, in fact, they have a hard time getting into the air, which is a problem. If you're a migratory bird, that's a fundamental problem. So what they do, after they have eaten all of this food and gained all this weight, and they are ready to go, in a matter of a couple of days, they get rid of their digestive system. Their intestines shrink by more than 50%. Their stomach and their liver and their kidneys atrophy rapidly, so they're losing tissue in their digestive system at the same time that the muscle mass in their pectoral muscles and their breast muscles increases by 30 to 50%, and the muscle mass of their heart increases by more than half. So basically, they get ripped and buff almost overnight without exercising. I kind of wish I were a godwit. And so having gotten rid of this extra weight that they don't need in their digestive system, and having gained all this muscle mass that they need to fly, they wait for a big, powerful storm to come out of the Aleutian Islands, which happens every couple of days at that time of the year, with 80 or 90 or 100 mile an hour winds. And once that storm passes and the winds shift out of the north, these birds take off and fly out into the open Pacific Ocean. That's Alaska, way up at the top there. There's Hawaii kind of part way down. And what these birds do is they take off into the open ocean, they go past Hawaii, they overfly all of the islands in the South Pacific, Fiji and Tonga and all the rest of them. They fly 7,200 miles non-stop across the widest part of the Pacific Ocean. Now, this was a migration system we knew almost nothing about until about 15 years ago. A guy named Bob Gill from the U.S. Geological Service in Alaska that was the person who's been studying this. And what Bob would do in the old days is he would wait for the first flocks to take off from Eisenbeck. And he'd contact his counterparts down in New Zealand and say, they're on their way. And then the Kiwis would go out and wait for the first flocks to arrive and say, oh, they're here. And it's crude, but what they were able to estimate that based on that, it was taking these birds 4 or 5 days to make that flight. Again, no food, no water, no rest. There are, as I said, essentially no records to suggest these birds are stopping anywhere along the way. Well, a couple of years ago, satellite tracking technology got miniaturized enough that Bob was able to implant satellite transmitters in the abdominal cavities of these birds and then track them in real time. And what you're looking at there is an actual track from the first bird that he tracked. And it turns out that they don't take 4 or 5 days to make that flight. And when you think about it, that's kind of ridiculous. The notion of a warm-blooded animal flying the equivalent of a human runner running sprints, 3-minute sprints, for 4 or 5 days. It's physiologically impossible. It doesn't take them 4 or 5 days. It takes them 7 to 9 days to make that flight. Birds do incredible things. They land in New Zealand. They stay primarily in the North Island at the Firth of Thames, which is this huge estuary system. They land, they regrow their guts, they start eating, they stay there for the austral summer, and then in March or April, as the austral summer starts to end, it's time for them to go back again. But they can't go the way they came because they were using prevailing winds to help them with that flight down there. And if they retrace that track, they're going to be flying into headwinds. So they go the other way. They fly about 5,000 miles nonstop from New Zealand to the Yellow Sea and China and Korea. Land, regrow their guts, hyperphagia, double their fat reserves, take off from there and fly another 2,500 to 3,000 miles back to Alaska. And so these birds, over the course of a single year, these bar-tailed godwits are going to be flying about 18,000 miles. They're going to be in the air flying for a total of 22 days every year, and they'll be averaging about 820 miles a day as they're flying. And this is a bird that can live for 25 to 30 years. By the time that godwit dies, it will have flown the distance from here to the moon and most of the way back. Birds do amazing things. Now, of the roughly 800 species of birds that we have in North America, the breeding species and the vagrants that come in here, probably about 500 of those species are migratory. But they're not all migratory to the same, epic extent that godwits and black-poll warblers are. And there's no one-size-fits-all, it's like there's a lot of shades to migration. There's a lot of approaches. When most of us think of migration, we're thinking of what scientists refer to as complete migration. And these are birds that have a distinct breeding range in the north, a distinct wintering range in the south. They all leave the breeding range and go to the wintering range. Ruby-throated hummingbirds, a great example of this. And this is a bird that breeds across all of eastern North America. We think of this as an eastern bird, but it's actually, you can see there's a huge range extension that goes all the way up into British Columbia. But in the fall, all of those ruby-throated hummingbirds fly, most of them across the Gulf of Mexico, and spend the winter down in southern Mexico and Central America. Complete migration. They completely leave the breeding range, go down to the wintering range. But there are lots of birds that take a more complex approach. Birds like bald eagles, where you have a tremendous amount of overlap between the breeding range and the wintering range. There are some areas where the birds are found, for example, where they're found only in the summertime, places where bald eagles are found year-round, and other places where they're found only in the winter. This is what's called partial migration, which is the dumbest term in ornithology. I mean, how can you partially migrate? I don't understand the rationale for that term, but it refers to bird species where there's, as I said, a lot of overlap between breeding range and wintering range, where some regional populations migrate, others don't. Perhaps some individuals within populations are more strongly migratory than others. And a lot of migratory birds fall in this category. Red-winged blackbirds, robins, red-tailed hawks, blue jays, the majority of migratory birds probably are partial migrants to some degree. And then you have birds like downy woodpeckers and cardinals and great horned owls that are completely non-migratory. They move out of their parents' territory, they find a place of their own, they settle down, and they don't budge for the rest of their lives. And then there are the birds that are completely unpredictable, the so-called eruptive migrants. And these are generally northern birds, either northern raptors like northern hawk owl here, great gray owl, boreal owl. These are birds, and also a lot of the northern finches, crossbills, purple finches, evening grosbeaks. These are birds that live in the north and are content to stay there summer and winter year-round as long as they've got enough to eat. But they depend on food resources that occasionally crash, either owls and hawks that are dependent on lemmings that go through these 4-year boom and bust population cycles where the lemming population crashes, the vole population crashes, or they're dependent on spruce seeds and fir cone seeds. And periodically those trees just don't mast, they don't produce any cone crop. And when that happens, they're forced to go south to find food. They don't know where they're going. They don't have a predetermined migration route or a predetermined migration or a wintering area. There's no predicting where these birds are going to show up. In 1991, the first northern hawk owl in a century showed up in Pennsylvania. And it was on this little farm up in the Poconos. You had to go back this long dirt road and then up the long rutted trail to the driveway to the farm. And people came from as far away as Arizona to see that bird. And the farmer, I went up there a lot to take pictures of it. It wasn't this particular owl, but I got to know the farmer fairly well, and he had a little stand where he was selling hot chocolate and hot dogs, and he was making pretty good cash on this. And he took me aside one day and he said, "This owl's coming back next year, right?" And I hardly had the heart to tell him, but no, I mean, that owl went back up to the subarctic and spent the rest of its life up there, had no reason to come south again. Which brings us to the first big question about bird migration, which is why do they do it? And I think this is one of those questions that's so self-evident. Why would anybody even ask the question? Well, obviously they're trying to get away from the cold. How many of you saw the March of the Penguins? Come on, yes. 70 below zero in the Antarctic winter, and the penguins are breeding. Birds can tolerate the worst weather this planet can throw at them. Birds don't migrate to get away from the cold per se. And a great place to understand that at kind of a visceral level is Cape Churchill in Manitoba, up on the shores of the Hudson Bay. In the summertime, Cape Churchill is a paradise for birders. More than 150 species of breeding birds, including some of the rarest birds in North America, like Ross's gull, that are found virtually nowhere else on the continent. And come fall, virtually all of those birds bug out, because in the wintertime, Cape Churchill is a place where nature makes a serious attempt to try to kill you. This is, the Cree call it Kiwantinuk, the land where the north wind rises. This is a place where you have, when you're bird watching, you've got to look over your shoulder because there are lots of polar bears out there. And all but about 24 of the species of birds that breed in Cape Churchill migrate, obviously. But you can learn a lot about migration by looking at the species that don't migrate. Species like this one. This is a willow ptarmigan, the common circumpolar grouse species that's found in Europe and Asia at high latitudes and all across the Arctic and subarctic in North America. This is a non-migratory bird. This is what they look like in the summertime, a very camouflaging mix of brown and buff and black. In the winter, though, they molt into this almost completely white plumage for camouflage against the snow. They grow long feathers on their feet that act like snowshoes so they don't fall through the snow. And they do something that's the reverse of what the godwit does. The godwit's guts get shorter, but the willow ptarmigan's intestines grow by 30 to 50% in the wintertime because they have to squeeze every single calorie that they can get out of the buds of those little dwarf willow and birch bushes that you see growing in the background there, which has to rank as the dullest diet in the world. Now, if it were 70 below zero and I had barely seen the sun in 3 months, and I had nothing to eat except something that makes cream of wheat look exciting, I would damn sure migrate. But migration is dangerous. You don't know where you're going the first time you do it. There are storms and wind and predators and exhaustion. You may get to your destination and discover that there's nothing for you to eat. Maybe there's been a fire or a drought, and it's dangerous to migrate. And if you don't have to, you shouldn't. And for a beautifully adapted Arctic bird like the willow ptarmigan, there's no need for them to migrate. It's not the winter, it's not the cold that drives a yellow-headed blackbird out of its marsh in Montana and sends it south. It's because in the winter it gets cold and the marsh gets sealed off with ice, and it seals off the aquatic insects and the seeds and the other things that bird needs to survive. When you think about it, the birds that are most highly migratory either depend on seasonally abundant or available foods like nectar or fruit or insects, or else they depend on seasonally available habitats like waterfowl. The ponds and lakes freeze over, and if they don't migrate south, they're going to be sitting out there on this frozen lake, literally a sitting duck for the first wolf or coyote or fox to come along. So they have to move south for that reason. So that explains why this Blackburnian warbler leaves the forests of Acadia National Park to fly south in the wintertime, because it's an insect-eating bird, and there are not enough insects in the forests of the north in the wintertime to supply the billions and billions of insect-eating birds that are here in the summer. Now, there are insects out there, and we have insect-eating birds that winter here. Chickadees, for example, kinglets, brown creepers. Those are all insect-eating birds, but there's not enough bugs for all of the birds that are able to breed here in the summertime. So that explains why that Blackburnian warbler flies south. But it doesn't explain why that Blackburnian warbler flies all the way to the foothills of the Andes. I mean, if it wants bugs in the wintertime, there are bugs in Tallahassee. There are bugs in Biloxi. I have been to Biloxi. I can attest to this in the wintertime. Why on earth fly so far at such great hazard when you don't have to? This has baffled ornithologists and puzzled them for a very long time. And the reason that we find it puzzling is because we think of these birds backwards. We think of these as northern birds that take this little short vacation south in the wintertime and then come back up here to MDI or Scudic Peninsula where they belong. When the fact of the matter is, these are tropical birds. Warblers, vireos, tyrant flycatchers, hummingbirds, orioles, thrushes, tanagers. These are all tropical families of birds. They are most abundant and most diverse in the tropics. They evolved in the tropics. And during these relatively brief interglacial periods, like the one that we're in right now, when North America does not have a mile-thick pancake of ice sitting on top of it, these birds are able to move back and reoccupy this huge, immense area with long summer days, in fact, in some cases, perpetual summer days, and an abundance of food, and then in the fall go back south, retracing the route of colonization that their species has probably taken many times. We've had 20 different ice ages over the last 2.5 million years. These birds have done this many times. And we can actually see this still happening today with species like pectoral sandpipers, which winter in South America and breed all the way up across the American and Canadian Arctic and subarctic, and they have actually crossed the Bering Strait and colonized eastern Siberia, and every year they move a little bit farther and farther and farther west across the roof of Eurasia. And in the fall, all of those pectoral sandpipers turn around and go back across Siberia and back across the Bering Strait and back across Alaska and Canada and all the way back down to southern South America, because that's where they came. Which brings us to big migration question number 2, which is how on earth do they find their way? Well, obviously, that's Grandpa up here. And, and he's saying, well, now, sons, you want to stay out of that field because there's hunters down there. Oh, the rice is especially tasty over here. Wise old elder leading the flock south. Now, with some exceptions, and actually, waterfowl like ducks and geese and swans and cranes are an exception where you do have young birds traveling in mixed age flocks with older birds where they don't have to learn to migrate. They're born with that instinct. But they learn specific routes and specific stopover points as they're going away. That's why you can get a bunch of human-raised whooping cranes and lead them south behind a giant white ultralight with black wingtips and teach them to fly from Wisconsin to Florida. And all you have to do is teach them once. You don't even have to teach them to go back. They'll fly back to Wisconsin on their own, and then every year thereafter they'll make that flight because they've learned that route. But every other bird basically comes out of the egg with this genetically coded set of instructions that tells them to fly in a certain direction at a certain time of the year for a certain length of time. It's not a conscious decision. The Swainson's thrush over here does not get up one morning and go, I've heard Guyana's nice this time of year. They don't know where they're going. They just know they've got to go. And the trigger for it, as is the trigger for most things in nature, they're not being chased south by the cold. I mean, they're migrating. If you've ever gone shorebird watching on the mid-Atlantic coast in August, when you're marinating in your own sweat, surrounded by this corona of salt marsh mosquitoes, it's not the cold that's driving them south. And they're flying at their fattest, so it's not hungry. The trigger for that migration, like most things in nature, is sunlight. The changing ratio of daylight and darkness through the seasons, the photoperiod, as the days begin to get shorter in the fall. It triggers hormonal changes in the bird's body, and it gets this itch that grows into this compulsion that eventually becomes this overriding command to fly. And they take off by their hundreds of millions at night, just after dark. This great exhalation of birds rising up out of the landscape. In World War II, when they had just invented radar, they kept scrambling the fighters in England because they thought the Luftwaffe was coming because they could see these shapes on radar. And the fighters would get up there and there was nothing to see. They called them radar angels. It kind of freaked them out. They didn't know what they were. They were flocks of birds taking off out of the English countryside and flying south on their migration. And we can still see flocks of birds today by the billions moving across North America on our more sophisticated radar. And so these birds take off and they're flying through the night sky. And they have to orient themselves. They have to navigate across the landscape. And they do this by tapping into spheres that we sophisticated humans are blind, deaf, and dumb to. They're looking up at the night sky, and they're using celestial orientation. Now, it's not exactly what the ancient mariners were doing. They're not looking at the pattern of the stars. They're not saying, the big W up there is Cassiopeia, so that means I need to make a left. It's not the pattern of the stars. It's the apparent movement of the stars and the fact that what's the one part of the night sky that doesn't move? The North Star, Polaris, right. They don't know from Polaris. They don't know about the Big Dipper. That doesn't look like a bear to them, I'm sure. It doesn't look like a pot. It's just the part of the sky that doesn't move, and that gives them their compass points. North, south, east, west. You have no doubt already figured out the flaw in this plan. The fact that some nights you can't see the sky because it's overcast. But these birds have a whole series of fallbacks. They can navigate by using the Earth's magnetic field. And we don't really know how they sense the Earth's magnetic field. We know that some species of birds, bobolinks, mallards, a lot of them have tiny little deposits of magnetic crystals called magnetite, either in their brain or at the base of their bill. And we used to think it was kind of like a little compass, just kind of pulled their nose to the north. But it's actually more wonderful than that. There is a visual component to it. Somehow these birds are able to visually sense the Earth's magnetic field. I would give an appendage to see the Earth's magnetic field. It must be magnificent. The house sparrow scrambling for French fry crumbs at the McDonald's can see that, and we can't. They can hear extremely low-frequency sound waves from seismic activity and ocean surf and wind and high passes in the Rocky Mountains that travel halfway around the world. Many of the seabirds that you see off the peninsula here are birds that navigate largely by smell. Little Leach's storm petrels, if you've had an opportunity to see Leach's storm petrels. These birds breed by the millions on some of the islands farther to the north of here. Places like Baccalieu Island in Newfoundland, where these little storm petrels that spent the winter in Antarctica come all the way back, following their nose back to the Gulf of Maine, back to the North Atlantic, back to Baccalieu Island, where they find their burrow in the dark among 4.5 million other Leach's storm petrel burrows by the way it smells. Birds do incredible things. So you have a young broad-winged hawk that's never been more than 1/4 of a mile from its nest in Maine or New Brunswick or Vermont, and it takes off in a migration by itself. Now, this is a diurnal migrant. It's traveling by day, so it's using the position and the apparent movement of the sun across the sky as its main migratory orientation cue. The band of polarized light that moves in concert and sync with the sun across the sky. It uses leading lines in the landscape like mountain ridges and river valleys, and it learns with experience. Its first migration, it's going to fumble around. It may get wind drifted to the coast. It's, there's ocean down there. I don't want to go that. And the next year, learn to cut the corner by following the ridges of the Appalachian South. If you go birding at Cape May, New Jersey in the fall, there's tremendous numbers of sharpshin hawks that come through there. And you'll look at them and you realize that 80% of what you're seeing are young sharpshin hawks because they haven't learned to correct for that wind drift and they've gotten pushed to the coast. If you go to Hawk Mountain or any of the other sites along the Appalachian mountain chain, the majority of the sharpshin hawks you see are adults. These are birds that got pushed to the coast the first year, but now they've learned to cut the corner in subsequent years. And so these birds start moving south. And broad-winged hawks are social migrants. When they're passing through New England and the mid-Atlantic states, it's often in small flocks of a couple of individuals to a couple of dozen. By the time you get down into the southern Appalachians, they're moving in flocks of perhaps up to 100. When it gets to Mexico, it is a wall of birds, 30, 40,000 broad-winged hawks in a single big seething kettle where they've gotten into a rising bubble of hot air, one of these big thermals, and they rise up. It's kind of like they take it's like they're riding the elevator to the top. They get this tremendous lift rising thousands of feet in the air. When they get to the top of the thermal, as the lift starts to diminish, then they set their wings and they fly off. They glide for miles as if they're taking the escalator down to the next thermal. And they can do this endlessly, rise up, glide down, rise up, glide down. They can travel from Maine all the way down to Costa Rica or Panama or Colombia and hardly flap their wings a single time on that trip. And they do this. They move from one world to the next. These are birds of two worlds. And this is something very difficult for us to really wrap our heads around because we're such a rooted species. You have a species like the black-throated blue warbler that breeds in the Appalachians and across New England and parts of southern Canada, including up in central Maine at Baxter State Park. And they take off from here, and literally in a matter of days, they trade moose and black bear and white-tailed deer and ravens for tropical environments in the islands of the Caribbean or along the Gulf of Honduras, suddenly they find themselves among macaws and venomous snakes and monkeys and all these wild tropical animals that they've never seen before. And yet they fit into these tropical environments like a hand into a glove. They are not wandering around wondering what to eat and trying to figure it all out. The moment they arrive, they know instantly where to go. They recognize the alarm calls of resident tropical species of birds that are warning them of dangers like monkeys that they've never encountered before, because it's all hardwired into their genes. These birds do not live in any one place. They live in this hemispheric whole. But it's a problem for them because, strictly from a conservation perspective, you look at the disparity in landmass between North America and Central America and the Caribbean. Most of our birds are not traveling down to South America. Most of them, unlike the black warbler, the vast majority of them are wintering right in here and right in here. And so if you look at the range of the black-throated blue warbler, I mean, as North American birds go, that's actually a relatively restricted range. But we're still talking about hundreds of thousands of square miles of country. But all of those black-throated blue warblers in the fall are traveling down here to basically 4 islands in the Caribbean and this thin rim in Central America around the Gulf of Honduras. So from a conservation perspective, the loss of even a single acre of wintering habitat down in the south may be as damaging to these species as the loss of dozens or hundreds of acres up in the north. And we think of these, we've got this notion from rainforest campaigns back in the 80s and early 90s. Save the rainforest, and one reason we should save the rainforest is because our birds depend on it. And it's true that some of these birds do depend on lowland evergreen rainforest, wood thrushes, for example, red-eyed vireos. But other species depend on other tropical habitats that you hear virtually nothing about. They depend on mangrove forests. For example, American redstarts do especially well in mangrove forests in the Caribbean. They depend on tropical savannas. They depend the habitat, the tropical habitat that is of the most importance to the largest number of neotropical migrant birds that leave North America and go to the tropics, are oak and pine forests in the high elevations of Mexico and Central America, which is a desperately endangered ecosystem that you hear virtually nothing about up here. But wherever these birds go, they attract people. This is a picture of High Island in Texas. Curious, anybody gone to High Island? Okay, be honest. Would you have gone to High Island if you were not a birder? No, a friend of mine says that High Island is a good place for recreational mosquito bites. It's on the coast southeast of Houston, fairly close to the Louisiana border. And every year, so many birders go to this little out-of-the-way place where if the wind is right, thank God you can't smell Port Arthur. They pump like $6 to $10 million into the local economy every year. And that's the reason why. This is a Doppler radar image of the western Gulf Coast. That squiggly line down the middle there is the Sabine River. That's Louisiana to that side, and Texas on that side. High Island is right up here above me, and that is not a thunderstorm. That's what several million songbirds looks like on radar. These are birds that took off the night before from the Yucatan Peninsula on their northbound migration. They have flown 18 or 20 hours nonstop across 600 miles of the Gulf of Mexico, and they're not even tired. And I can say that because if they were tired, they'd be stopping right along the coast, and instead they're pushing farther, deeper inland. And generally what these birds are trying to do to get to these huge bottomland swamp forests deep in the interior. They're like 5-star hotels for birds. Lots of food, lots of shelter, lots of space for them, protection from predators. And they were able to make this flight so easily and in a relatively short time because when they took off from the Yucatan, they did so with south winds blowing up, tailwinds basically pushing them across the Gulf. But they don't have Doppler radar. And so a couple of times every week in the spring when these birds are flying north, they take off with these little gentle zephyrs under their tail feathers, and they get halfway across the Gulf and they slam into a cold front. And headwinds and rain and dropping barometric pressure and lowering temperature. And instead of making this relatively easy flight of 18 or 20 hours, it takes them 25, 35, 40 hours fighting across the Gulf. You've ridden a bike into a headwind. Can you imagine being that big and flying into a 30-mile-an-hour wind for 2.5 days? When they make it finally across the Gulf, those that make it, because millions of them will die in the course of that Trans-Gulf Passage, the ones that make it, as soon as they see land, they come bombing out of the sky. And it's a phenomenon called fallout. And that's why people go to High Island in Texas, and Grand Island in Louisiana, Dauphin Island in Alabama, or Fort Morgan, Alabama, where this picture was taken. These migrant traps, these are like a fire escape for these birds. There's not a whole lot of food, there's not a whole lot of water, there's not a whole lot of shelter. They overfly this habitat most of the time when the conditions are good, but it's like a fire escape on your house. You may not need it every day, but when you need it, you need it. And without this habitat, these birds are doomed. And so every year for the last 15 years, I've been going down to Fort Morgan, Alabama, working with a group of researchers that are studying this Trans-Gulf migration. We go down there in late March and April. We set our mist nets in the woods. We catch these birds harmlessly in these mist nets. We put small numbered leg bands on them. This is a Swainson's warbler, a real good bird, a hard bird for birders to get. This is one of the best places in the world to see them. We catch these birds, we weigh them, we see how much fat they have, and then we recapture these birds again over the course of several days and see how rapidly they're gaining their weight back. We're able to compare the quality of habitat in oak forests versus pine forests versus hackberry thickets to see what habitat is best for these birds. We do this for a lot of reasons. We do it because, frankly, for somebody who loves birds, it's a privilege to be able to work that closely and that intimately with wild birds. We interrupt their migration for just a very brief time, for just a couple of minutes to get this vital information and let them go. We do it in part for the education value because we're working in a state park where we get 500 or 600 visitors a day sometimes, and the ability to be able to put a ruby-throated hummingbird in the hand of a child on their palm where it sits for just a couple of seconds before it takes off, or allow a 90-year-old woman to hold a scarlet tanager in her hand and then open the hand and watch it fly away. You create conservationists that way. But we also do it because we're scared. Because the populations of almost all of these birds are a fraction of what they were just decades ago. If you've been a birder for any length of time and you don't think there's as many birds as there were years ago, you're absolutely right. We've got good, strong evidence of that. There are archived radar images, not Doppler, but old-fashioned radar images, all the way back to the late 50s and early 60s, showing that the frequency of these huge trans-Gulf migrations, like the one I showed you, have declined by 50 to 75% in the last 40 years. And there's a lot of reasons for that. Many of these birds that are in decline are interior forest nesting songbirds, like wood thrushes, that evolved to nest deep in the interiors of unfragmented, unbroken, contiguous forests. They nest relatively close to the ground, or in some cases on the ground. Their nests are fairly vulnerable to predators, but in these big, deep, dense, huge forests, there are relatively few predators. Well, I live in Pennsylvania. Pennsylvania is still 70% forest, but it is not an unbroken blanket of forest. It's been chopped into a million tiny little pieces by highways and roads and development and strip malls. And when you fragment forest, when you go from this unbroken blanket that once covered most of eastern North America, these tiny, tiny little fragments, you allow in what are known as edge predators, animals like skunks and raccoons and possums, blue jays, crows, black rat snakes, animals that avoid the interiors of forests but are very effective nest predators. You open the forest up to brown-headed cowbirds, which are nest parasites that were never even found in the East. It was a rare bird in John James Audubon's day. But these cowbirds will find the wood thrush nest and throw out the wood thrush egg and lay its egg in place. And the wood thrush ends up raising a clutch of cowbird instead of a bunch of baby wood thrushes. And all of these pressures are driving these birds lower and lower. They're losing habitat in the tropics as well. They're getting hammered on both ends. We're seeing increasing numbers of particularly forest nesting songbirds and grassland birds in rapid decrease. Migration has always been fraught with all kinds of dangers. It's always been hard. But we've made it harder. To wind and storms and exhaustion and predators, now we've added agrochemicals and lighted skyscrapers, and wind turbines and communication towers and feral cats, a whole host of humans, speeding cars, all these things that kill birds that are cumulative and on top of the natural losses that these birds already suffer. We've made it a harder and harder world for these birds, and now we're making it a hotter world for them. This is the big enchilada for bird migration and for bird migration conservation. What is the effect of climate change? And to be perfectly frank with you, I don't really care what your politics are. If you don't think climate change is real, and if you don't think we're at the root of it, and if you don't think it's happening now, you need to wake up and smell the coffee, because the birds are already reacting to it. We can see this in studies like the one the National Audubon Society did a couple of years ago, where they analyzed a century worth of Christmas bird count data and found that the average center of abundance for wintering bird populations for each species has shifted by an average of 400 miles to the north in just the last 40 years. Birds are already sensing climate change. They're already reacting to it. Some species of birds are arriving as much as 2 weeks earlier in the spring and leaving 2 or 3 weeks later in the fall. This is the phenology that Seth was talking about. That's a really important area of study. But we also know that the birds that are reacting that way and seem to be flexible and adaptive in the face of climate change are the short and moderate distance migrants, the ones that are mostly wintering in the central and southern United States, that can kind of sense it's a warm spring this year, so I can migrate north first, or earlier, I should say. The long distance migrants, the blackpoll warblers, the Blackburnian warblers, the scarlet tanagers that are coming up out of Central and South America, they don't know what the weather's like up here. They're coming back exactly the same time on average that they did 100 years ago. But they're coming back to a forest that's leafing out earlier and earlier and earlier, full of insects that are emerging earlier and earlier. And we're right on the cusp of starting to see a disconnect between the arrival of these birds and the initiation of their breeding season and the peak abundance of the food. I mean, they time their migration so they come back and are able to establish their territory and build their nest and lay their eggs so that their chicks are hatching just at the peak of abundance of soft-bodied insects, mostly caterpillars, in the forests of North America. And if those caterpillars are emerging weeks earlier, they're going to pay a price. We're not seeing that yet in North America, but it's happening in Europe with trans-Saharan migrants like pied flycatchers, whose populations in some parts of Central Europe have dropped by 95% in just the last 10 years. That's what may be coming down the pike for us. So now that I've depressed you all, there's actually a lot that we can do in our daily lives to make a demonstrable difference for migratory birds. And I'm not suggesting that you have to abandon your life and move to the woods and build a hut made out of twigs and eat tree bark. Although, if that floats your boat, I'm not going to stand in your way. But I'm not willing to do that. But we don't have to. We can just make some simple changes in our lives that will really help migratory birds. One of those things that you can do, right there we go, is landscape with nature in mind. And what I mean by that is, instead of planting zinnias and marigolds and calla lilies and Korean dogwoods and all these exotic plants from other parts of the world that have absolutely no ecological connection to the landscape in which you live, landscape with native plants, with native shrubs, with native trees. Every time you plant a native wildflower or a native shrub, you're knitting together broken ecological connections, and you're creating an oasis for birds and other wildlife. And there's a lot of advantages to working with native plants. First of all, they're pre-adapted to the climate. They're pre-adapted to all the local pests and diseases. You don't have to spray them with chemicals to keep them alive. You don't have to pump them full of fertilizer. They're pretty much drought-proof. And in fact, the insects that do eat them, don't think of them as insect pests. Think of them as bird food. You're creating direct food for the birds in terms of the bugs that are attracted to those plants, and also in many cases to the seeds and fruit that those plants provide. And you're not giving up anything in terms of beauty. These are just random pictures from our backyard in Pennsylvania. The last time I counted, we have about 275 species of native wildflowers, shrubs, ferns. And as you're creating this network in your backyard, as you're restoring these ecological links, please be organic about it. You can be a lazy gardener, because if you're working with native plants, they don't need all that chemical help. And you don't want to create a backyard oasis for birds and then soak it full of toxic chemicals. And while you're being organic in your yard, you should also buy organic when you go to the supermarket. It's remarkable how many species of migratory birds spend part or all of their life cycle in agricultural landscapes, either in migration or during the wintering grounds, sometimes even during the breeding season. It's better for the birds, it's better for you, it's better for the people, often in Latin America, who are working for almost no money on those farms. So I was pulling out my hair last year. You may have seen the study from Stanford University that compared the nutritional value of organic and non-organic and said there didn't seem to be any reason to buy organic because there seemed to be no nutritional difference between the two. Way to miss the point, guys. You know, it's better for the planet, it's better for you as a consumer, and it's a whole lot better for the birds if you buy organic. Now, here's a really simple one. If you own a cat, please keep it inside. They call them house cats for a reason. It is hard to overstate the damage that free-running cats, both pet cats that are fed and truly feral cats, the damage that they inflict on wild birds every year. And this is an emotionally fraught topic. The cat people and the bird people are mostly talking past each other, mostly screaming past each other. But this is a problem that we need to solve. The most recent estimates are that free-running cats probably kill between 2 and 4 billion birds a year in North America. I talked about human-induced mortality that wild bird populations can't tolerate. There's a really easy one that we can fix. If we spay and neuter, if we keep our cats inside, feeding your cat does not stop it from killing birds. Putting a bell on your cat does not help. Birds don't know what bells are. Declawing your cat doesn't really even help. Keeping your cat inside is better for the cat. They don't contract feline leukemia. They don't get eaten by coyotes and great horned owls. They don't become a fur pancake on the road. If your community announces plans to create what's known as a managed cat colony or a trap, neuter, and release colony, scream bloody murder. These are colonies of feral cats that are trapped, neutered, given their shots, and then put back in the wild and fed. And the theory is that eventually the colony, because they're not breeding, will dwindle down. But in practice, what happens is enough of them aren't neutered that they keep reproducing, and people keep dumping more cats, and they become permanent colonies of subsidized predators that don't function like wild predators. A wild predator doesn't get enough to eat, it dies. But these feral cat colonies can just wipe out the local bird population, and it doesn't affect their getting 3 squares a day. I love cats. I've owned a lot of cats over the years. I've never had a cat that went outside. It doesn't make them neurotic, but it makes the local birds a whole lot safer. Now, this is going to seem like a particularly specific recommendation to use recycled paper. And the reason, I mean, we're all good environmentalists here. I'm sure we recycle everything and we try to use recycled products. But the reason I want you to specifically look for recycled paper when you're buying paper products is because most of the paper that we use here in the United States comes out of the boreal forest of Canada, which is the largest intact forest left on the planet. 1.5 billion acres stretching from Newfoundland to Alaska. And it is a bird factory of global significance. More than 220 species of migratory birds coming out of the boreal forest every year, probably about 20 or 30 billion of them, loons, pectoral sandpipers, savanna sparrows, whooping cranes, surf scoters, bay-breasted warblers, you name it, they're coming out of the boreal. And we're chopping the boreal forest down, virgin forest, to make Kleenex and toilet paper and magazine and catalog pages. This is not the wisest and best use of the largest remaining forest on the planet, and especially one that's so important for migratory birds. Here's some really good news for you, which, because most of us are Americans, and this took place in Canada, you know nothing about because we're very good at ignoring Canada. But a couple of years ago, there was the conservation success story to beat all conservation success stories in the boreal forests of Canada, where you had a coalition of First Nations tribes and environmental organizations and the biggest extractive industry leaders in Canada, the forest products producers, some of the biggest mining companies, that got together and said, we are going to preserve mind-bendingly big chunks of the boreal forest in permanent conservation The way we normally do conservation is we develop almost everything, and the little scraps are left, and we save them as islands of conservation in this matrix of development. The plan in the Boreal is to create this matrix, this landscape, continental level matrix of conservation, in which are these smaller, isolated pockets of sustainably certified development. The forest products industry has pledged to have their operations certified as sustainable by the Forest Stewardship Council within a reasonable amount of time. This is huge. This is an absolutely huge victory for migratory birds. We can't let up the pressure, and we still need to make sure that we're buying recycled paper. And then finally, I want to urge you to drink more. And I don't know about the people you've heard with. People I've heard with, I've got to be specific that I'm talking about coffee here, not something a little bit more intoxicating. And Seth has already touched on this a little bit, but this seems like another one of those kind of weird, doesn't make a lot of sense connections to migratory birds. But if I show you these three pictures, and I ask you to pick out pictures that show a crop under cultivation, well, I mean, obviously, it's the one up here where everything's planted in nice, neat rows. But actually, all three of these are pictures of coffee under cultivation. The difference is that these two are photographs of what's known as traditional or rustic shade coffee. This is the way coffee has been grown in Latin America and the Caribbean for hundreds of years, where a farmer would go into the shade of an existing intact forest and plant a few widely spaced coffee shrubs along with perhaps some breadfruit or bananas or a few other things. And it's probably got the lightest agricultural footprint of any agricultural system in the world. The sad part is, increasingly, it's an endangered agricultural system. Increasingly, what had been these rich, fertile, biodiverse forests, which are essentially untouched forests with a little bit of agriculture going on down in the understory, have been bulldozed to create sun coffee plantations, because we Americans love cheap coffee. And if you buy your coffee in a can at a supermarket, you are buying sun coffee. The reason that this matters is because hundreds of species of neotropical migrants that leave North America every year for the tropics depend on shade coffee plantations, either as their main wintering area or as important migratory stopover sites as they're moving between North and South America. Species like Baltimore orioles, blue-headed vireo, chestnut-sided warbler, western tanager, western kingbirds, broad-winged hawks, the list goes on and on and on. There's less and less of that habitat out there. About 40% of the shade coffee plantations have already been lost. And as I said, we're the ones driving that because we want cheap coffee. Americans drink a third of the world's coffee supply. That's the bad news. The good news is Americans drink a third of the world's coffee supply. So if we make the right decisions about the kind of coffee that we drink, we can make a huge difference for preserving some of the best migratory bird habitat that we have in the Western Hemisphere. And there are a number of certification programs out there. The Rainforest Alliance has one. There's some others. But the gold standard for certifying these shade coffee farms, the coffee farms that have the very best quality habitat, are certified by the Smithsonian Migratory Bird Center at the National Zoo in Washington. Dr. Russ Greenberg and Bob Rice and some of the other scientists at the Smithsonian came up with this so-called bird-friendly certification program about 20 years ago. And there's this long raft of criteria that the farms have to meet. The canopy of the forest must be all native species. There have to be intermediary subcanopy layers. There have to be a certain percentage of lianas and vines per hectare, stream buffers. The farm must be USDA organic certified before it qualifies as bird friendly. It's by far the most rigorous of the certification systems out there. There is a whole raft of peer-reviewed science to show that these high-quality Smithsonian-certified farms, when you're looking at whether you're looking at bird biodiversity or reptiles or amphibians, orchids or butterflies, they're always just a couple of percentage points below intact virgin forest, whereas all the other types of coffee production are a fraction of that, and sun coffee is basically the ecological equivalent of a parking lot for birds. I love this quote from my friend Bridget Stutchbury. Bridget is one of the world's leading researchers on migratory birds. She's at York University in Canada. She wrote a book a couple of years ago called The Silence of the Songbirds. And I love this quote of hers about you know, the ghosts of warblers and thrushes in the swirling steam of your coffee mug. And I think she meant that poetically, but if you're drinking sun coffee, it's literally the ghosts of the birds that used to use that habitat that no longer do. I mean, coffee is one of these weird situations where there's no middle ground. You're either buying coffee that is actively destroying bird habitat, or you're buying coffee that's actively preserving. And Ken Kaufman, the author of Hoffman Field Guides, if you're a birder, you know Ken. He's actually going to be at Hog Island next week. And he and Bridget and a number of us have become real supporters of Smithsonian bird-friendly coffee. And as he says, you know, specifically, why aren't more birders specifically asking for it? This is a simple thing that those of us who love birds can do to make the world a better, safer place for these birds. Seth mentioned Birds and Beans. That's a company that I'm involved with, and Ken and Bridget. But frankly, there are a bunch of other companies that sell Smithsonian migratory bird coffee. Cafe Ibis out west, Birds and Beans Canada. If you live anywhere on the West Coast, the Fred Meyer food supermarket chain sells it in their supermarkets. I don't care who you buy it from, frankly, but look for that bird-friendly seal because it makes a huge difference for these birds. And at the end of the day, the birds are already doing everything they can. I mean, they have pushed themselves to the limit of physiology. They've pushed themselves to the limit of what it's possible for a tiny little vertebrate to do. Every year, these birds take everything they are, their entire genetic legacy stretching back millions of generations, and risk it all on another flight south, on another roll of the dice. These birds are already doing everything they can. The rest of it is up to us. I want to thank you very much for coming out. I want to thank Seth and the folks here at CERC for having me, and I wish you a good evening. Thanks.
Well done. If anyone has any questions, we can do a few questions, but we need to do it with microphones. So if you don't mind.
And put it right up to your chin.
Okay, this has been driving me crazy since you talked about the godwit. How did the first godwit figure out that migration route?
Well, it's incremental. It's incremental. These birds start a little bit and come back and go a little further.
But it's across the Pacific.
Oh, well, there's such a thing as dumb luck. You know, I can't answer the godwit question for you, but there's a really fascinating hypothesis on black-pole warbler migration. Remember the one that goes east to west and then all the way out across the Pacific Ocean? At the peak of the last ice age, when North America was covered in glacial ice, you had these incredibly powerful so-called katabatic winds that were blowing from west to east across the hemisphere. And at the time, sea levels were hundreds of feet lower than they are now. And so the Bering Land Bridge was an ice-free area that probably had a lot of good black-pole warbler habitat. And the whole continental shelf here on the East Coast was spruce forest for, you know, all the way out to what's now the edge of the continental shelf, where mastodons roaming around 150 miles further out to what is now ocean. And so getting from the Bering Strait to the East Coast was a case of catching these katabatic winds and getting flung across the continent, and then flying south across what at the time was probably largely dry land. The islands, these what are now little islands of the Caribbean, most of the Caribbean was dry land. So that it's possible that black-pole warbler migration evolved at a time when the route made a lot more sense. And as the climate changed and the sea levels rose, those birds, they're still able to do it. But they may be at the edge of what's possible. And one of the issues with climate change is if the climate projections hold, in a century, the boreal forest that those birds depend on will have migrated another 1,500 miles farther north into the Arctic archipelago of Canada. Now that's assuming that spruce trees can migrate that rapidly, which is a very open question. But the question I wonder about is it possible for a black-pole warbler to make that flight with an extra 1,500 miles added to it? I don't know. We're going to find out. Yes. Oh, I'm sorry.
Are there any fascinating theories that you know about why these birds that are southern birds migrating north to breed, how come they don't breed in the south?
That's a really good question. Whoa, sorry. Why don't these birds breed in the south? Because there's a tremendous amount of competition down there. Because those tropical habitats, those tropical ecosystems and niches are already filled with resident species. And it's actually a fairly dangerous place to breed. When you look at annual productivity rates between birds that breed in the temperate zone and birds that breed in the tropics, the birds that breed up here raise more chicks every year than the ones that breed in the tropics. Because in the tropics, in addition to all the usual other things, you've also got many more snakes, you've got monkeys. You don't have to worry about monkeys in Maine reaching into your nest and damn those primates. Now the tropical birds make up for it because they live longer. So over the course of a lifetime, on average, they're producing roughly the same number of chicks. But it's an off-season thing. They're able to go down there and just focus on themselves. They can find a place where they can feed themselves. And what also often happens is that many of these migratory birds undergo this kind of Jekyll and Hyde change in their ecology. For those of you who are birders, you know, the eastern kingbirds, the quintessential flycatcher. It's a ferociously territorial, entirely insectivorous bird. It eats nothing but insects, which it catches out of the air. They're so good that they eat bees. They catch them and they pluck the stingers out of them before they eat them. And any other kingbird that comes within their territory is going to get its head taken off. But as soon as they go across the Gulf of Mexico and get into the tropics, they become gregarious fruit eaters. They form these huge flocks that move down through Central America and into South America, following the fruiting of different species of tropical trees. And then they come back up and they fly across the Gulf. We catch them in Alabama in the springtime with the pulp, the dried pulp of tropical fruit on their beaks. And as soon as they come across the Gulf, they're back to being ferociously territorial insect eaters. Red-eyed vireos that are breeding right here in the peninsula. They eat nothing but insects all summer long. As soon as they get into South America, they feed on fruit. And so you really can't raise chicks on fruit. So if they were trying to feed on insects, they'd be in direct competition with the resident birds. And by the way, I should also say people often ask about South Americans, why don't South American birds migrate north? And the fact of the matter is that there are South American birds that migrate north. They're going from the southern cone of South America into the Amazon and Orinoco basins. There's not many of them because there's not much land mass down there. But as our birds are leaving South America to migrate north, that's when these austral migrants are moving in, and so you have this replacement. So the resident birds, every 6 months there's a changing of the guard, and a new group of migrants are coming either from the north or from the south. And we're just starting to understand some of the complexities of that austral migration process.
What about the terns, though? The terns?
Well, there are terns that nest in the there are species of terns that nest in the subarctic, in the subantarctic, I should say. There's a really good example of this. Two closely related groups of birds that basically exchange hemispheres. Leach's storm petrel. You know, that's the bird that nests on Bakalu Island that I talked about. That's the northern breeding species, and then there's Wilson storm petrels that breed in the islands around Antarctica. And in our summer, all the Wilson storm petrels come up and feed in the North Atlantic, while the Leach's storm petrels are nesting. And then when our winter comes on, both species move down to the southern oceans where the Wilson storm petrels breed, and the leeches spend the off-season much, much farther offshore, feeding and building their fat reserve. And they're just sloshing back and forth on a seasonal basis across the oceans. Yes?
Excuse me, it's my turn.
It is. Thank you for your patience.
What birds eat the most?
Put it right up against your mouth.
What birds eat the most black flies? And how can I attract them without attracting more black flies? And secondly, how many nights a year do you dream you're flying?
The answer to your first question is none of them eat enough black flies. But I will tell you something that black flies and mosquitoes are a crucial resource for these birds up here, and particularly for the more active fly-catching birds like the flycatchers, but even cedar waxwings, for example, which do a lot of hawking and flying up. And of course, if you like Maine blueberries, the really wild Maine blueberries and across Canada and Alaska are for the most part pollinated by male mosquitoes. So there's a little something for you. As far as the dreams about flying, you know, according to Freud, a dream about flying is just our mind's way of talking about sex. Freud was not a birder. For those of us who are birders, sometimes a cigar is just a cigar, and a dream of flying is just because we really want to be a bird. It happens to me a lot.
You mentioned the daylight being the trigger for some migrations.
Right.
And then at a later point, you sort of indicated that it might be a food source.
Well, okay, there are what are known as proximate causes and ultimate causes.
That's what I was going to ask. So the birds that are food driven would be the ones that change.
They're all food driven. That's the reason migration as a whole happens. But the trigger in the individual bird, the physiological trigger that gets the bird into migration condition, is photoperiod. And I would say that photoperiod is the ultimate cause, and then the proximate cause, the one that triggers the bird to migrate today as opposed to tomorrow or as opposed to the day after, is weather. So the changing photoperiod gets the... I'll step back even further. Food resources are what has forced that bird to become that species to be a migrant. So food resources are changing the species as a whole. The individual bird comes into migration condition in spring and fall because of the changing photoperiod. That's what causes these hormonal changes that allow the bird to start depositing fat. They only deposit fat in significant amounts during the migration season. Catch a bird in the middle of the breeding season, has very, very little fat, no matter how much it's eating. And then once the bird is in migration condition, then the weather is going to trigger it to go today versus yesterday or versus the day after. When a cold front comes through in the fall with north winds that will push it south, or a warm front in the spring with south winds. So you're looking at different levels that all come together to send that bird south.
Okay, but a bird, say that, I forget the term you used, but say like a northern cardinal. Mm-hmm. They might move around, but they don't really migrate.
They're not migrating.
When we moved to Maine, there were no cardinals. Now there are cardinals everywhere.
Okay.
And is that food driven?
Well, it's probably climate driven. There's a lot of southern species, but what's happening here, it's not migration. What's happening is each generation, these cardinals are dispersing out of their parents' territory and moving away, and so you have birds like cardinals, black vultures, turkey vultures, red-bellied woodpeckers, Carolina wrens, northern mockingbirds that are pushing farther and farther and farther north with each generation, but they're not migrating back. They stake out a beachhead, they become, they settle down there, they stay there, and then their progeny move a little bit farther north and a little bit farther north. And that's been happening, for much of the last century. That's partly climate driven, that's partly habitat change as we've altered the landscape. Is there, yes?
You mentioned a bird that absorbs and then regrows its gut at the beginning and the end of its migration.
Yes.
How do they do that?
We're not really quite sure. This is the great thing about science. I love saying I don't know. How do bar-tailed godwits grow and shrink their guts? I shouldn't say we don't know. There are physiologists working on this, and they're starting to understand the enzymatic cycles that drive it. But we're a long way from being able to reproduce that in people. Imagine if you could give somebody a pill that would shrink their intestines by a third. That's like the ultimate diet pill. But I'm waiting for the pill that gives you 50% more muscle mass in the upper body.
We'll take one more question.
I don't know if this is a good one, but in your book you talked about the Central Mexico, Central American sort of islands that birds can migrate to, and I don't know if you want to mention that. Places where habitats retain.
Oh yeah, sure. And and in fact, this is a great example of that. We're talking about these about shade coffee. My wife and I were down in Nicaragua in January. We visited a number of the farms that the Smithsonian Migratory Bird Center coffee is coming from. And one of the areas is the highlands of northern Nicaragua up toward the Honduras border. And it's when you look at it from space, like on Google Earth, it's this green island surrounded by all this denuded landscape. And I have literally, in 25 years of traveling in Latin America, never seen as many neotropical migrants as I did on these shade coffee farms. And you sit up on the mountain and you look out to the horizon, just these rolling, lush green hills that look like just untouched forest. And it's all shade coffee. It's all organic. Most of it has now been certified by the Smithsonian. And it's an oasis for the birds. I mean, the diversity of neotropical migrants, and also resident species of birds, and butterflies, and orchids, and mammals, and everything else in those areas that these farms are preserving, compared to the stripped land around it that's now cattle pasture or sun coffee plantations, is just incredible. It's why I say it's hard to overstate how important shade coffee farms are for those birds down there. And it's really good coffee. And this is ironic. I talk about coffee all the time. I don't even drink this stuff. But my wife is the world's great coffee addict. And she was in nirvana down in Nicaragua, getting this wonderful shade-grown coffee, freshly ground, freshly roasted. It was really hard to get her to go back on the plane and come home. So, anyway, I will continue to talk about migratory birds until your eyes roll back in your head. But we'll let you get up and walk around before that happens. Seth, thank you very much. I really appreciate it. Thank you all.
Thank you. Excellent. Thank you all for coming out. Please help yourself to some dessert and that beautiful coffee that's out there in the hallway. And don't forget to look for the scholars. They have name tags on and you can chat with them. They know all about migration too. And Scott will be around in case you want to talk to him individually. Thanks again for coming out.